Today we are talking about 1.5, which is on inverse functions. And so basically everything that we do in math has an undo button, right? If we add something, we can subtract something. If we multiply something, we can divide by something. And so this is the same idea with inverse functions. So if I have a function that adds 9 to x, then I can find a way back by subtracting 9 from x. So, for instance, I just want us to take a look at here at x and values here. So if I just plug in a few values into my f, x plus 9, and when I plug in 0, I get out 9. If I plug in 1, I get out 10. If I plug in 2, I get out 11, right? So then let me go back to then this is what I'm saying. This little notation here is read f inverse of f. It looks like a little -1 power. It's not actually an exponent, it's a symbol that we use to represent the inverse of f. Okay, so I'm going to plug in values of x into my x minus 9. Now I'm actually just taking the values that I got out here and putting them back in here because then it takes me back to the 0. So when I plug in 9 in for x, I get 9 minus 9, which is 0. When I plug in 10 for x, I get 10 minus 9, which is 1. And 11 gives me 2 back. And so because, right, for my f takes 0 to 9, and my f inverse takes 9 back to 0, we say that f and g, this is an example of what inverses do. Okay? So basically, if you think in pictures, right, so if this is my domain of f, right, then it takes my domain of f, it takes it over here to the range of f, and then my domain of f inverse then takes me back to my domain of f. So over here, I get the range of f inverse. So essentially what is happening is what was x for my function is now my y of my range, right, of my inverse function, and my y of my domain, or y of my function f, is now my x of my inverse. So basically, the x's in my original function become my y's in my inverse, and my y's in my original function become the x's in my inverse. Okay. So the definition of an inverse function, now that we've talked about compositions of functions, so the definition of an inverse function is if f and g are inverses of each other, then f composed with g, meaning when I plug in g in for f, I get out x for every x in the domain of g, because I have to check g first, right? Because that's my inside function. And the same thing happens when I compose them in the different order. So if I plug in f into g, I also get out x for every x in the domain of f this time, because f is my inner function. So if these two things are true, right, if I have f composed with g is x and g composed with f is also x, then we can say that f and g are inverses. So then we can say that g is equal to f of x, or f inverse of x. Then this is the same composition. It's just instead of g, I'm writing f inverse here. So that means that if I put f into f inverse, I get out x, and if I put f inverse into f, I get out x. So this is just composition. And then this is just kind of like formally stating what I said up here, that the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. Okay? So I'm literally, in many cases, just flip-flopping. The x and y's become opposite. Okay? So for instance, let's use our definition to verify that f of x here is x is the square root of x, and f inverse of x is x squared. We want to verify that these are in fact inverses. I'm using the notation, but let's try it anyway. So if I have f, so I'm using the definition that when I compose them in either direction, I should get plain x. So let me put f on the outside first of f inverse of x. So I'm just going to compose them. That means I'm going to take f, and I'm going to plug in x squared. Okay, so here's my f, And so I'm going to take the square root of x squared, right? I'm plugging in x squared in here for x. And the square root of x squared is x. So this is good. It's looking promising. So now I have to compose it in the opposite direction. F inverse of f of x is equal to, okay, so this time my f inverse is x squared. So this time I'm going to do f of the square root of x, right? Because that's what f of x is equal to here. And so now I put in the square root of x, and I square it, because this is what f inverse tells me to do, and I get out x. So basically I've algebraically verified that this f and f inverse, as I so called it, are in fact inverses of each other. Okay. So, let's just look at a graphical. So let's look at, for instance, let me change papers here. Right. So I want to look at f and see if we can just sort of like informally right now figure out what f inverse is. Okay. So I have f of x is 3x minus 1. So I'm going to use the idea of basically exchanging my range and domain here and see if I can come up with my own f inverse. Now there's an algebraic way, but I just kind of want to go through this because I think it kind of helps solidify what an inverse is here. So I'm going to plug in values into my f. So I'm going to try to find out what the inverse of f is. Okay. So I have 3x minus 1, so I'm just going to plot a few points here. If I plug in 0, I get out negative 1. If I put in 1, then I'm going to get 3 minus 1, which is 2. Let me just plot, let me put negative 2 in here just to have a point in the back. So I have negative 6 minus 1, which is negative 7. So I have 0, negative 1 here. I have 1, 2 here. And I have negative 2, 1, 2, 3, 4, 5, 6, 7 here. Okay, so I do recognize this is as linear, and so that means that really my 2 points probably would have been enough. I'm a little off with my graph here, but so this is my graph. It's supposed to look like a straight line. It's not the best straight line I've ever drawn. We'll just kind of fudge this point over here a little bit. Okay, that's what happens when you draw by hand. Okay, so I have this kind of informal graph. So what I want to do is I'm going to just take and I'm going to, so f inverse basically changes my x and my y. So basically I'm just going to write these as flipped. So here my x would be negative 1, my y would be 0. Here I'm going to plug in 2 and get out 1. Here I'm going to plug in negative 7 and get out negative 2. Okay, so let's plot these as well. All right, so I have negative 1, 0 back here, 2, 1 here, and negative 7, so negative 1, 2, 3, 4, 5, 6, 7, and negative 2 is back here. So this is also a straight line. Now I haven't done a very good job here, but if I'd have plotted more points on a more precise axis, then I would have seen it. So this is f, and I'm saying that this is f inverse. Now, since this is a line, this is a good place for us to practice writing equations, okay? So I'm saying that f inverse is a line, and so I want to write an equation for f inverse, okay? So I'm going to use these points. Based upon my picture, I'm kind of guessing that this is a straight line, so I'm going to write a linear function. So I'm going to use the point negative 1, 0, and 2, 1. I only need 2 points to write my linear equation. Okay. So first I need my slope. So my slope will be, so I'm going to go in this direction. My slope is the y's on top, so 0 minus 1, and then negative 1 minus 2. So this is negative 1 over negative 3, gives me positive 1/3. Okay. So that's my slope, and so now I can write the rest of my equation. I'm going to use this particular point to plug it in. So I get y minus 0 is equal to 1/3 times x plus 1. Right? So again, in the end, really, I almost have slope-intercept form here if I drop this y equals 0, and I'm just going to distribute my 1/3 x plus 1/3. Right? If I ask you to write an equation, the point slope is fine, but in this case, I have this going on. Okay? So hopefully my graph sort of looks like it represents that, right? It definitely looks like it's got a flatter slope of 1/3, and I've done a reasonable job of kind of showing that my y-intercept is approximately 1/3. Okay, so based upon this, then I can call this f inverse of x is equal to 1/3 x plus 1/3. Now maybe I should compose them in both directions just to double check and make sure that I've not gone crazy with my ideas here. So let's do that. So let's take f and plug in f inverse of x. Right? So that means I'm going to have f of 1/3 x plus 1/3. Right? So that means I'm going to have 3 times, okay, so I'm taking it and putting it, this is my f. So this is what I'm doing here. I'm taking this, so this will be 3x minus 1, and then this is my new x. All right, so to simplify here, I get 3 times 1/3 x, so that gives me an x, and then I have 3 times 1/3, which gives me plus 1 minus 1, and I do end up getting x. So this is a good start for me. So let's try in the opposite direction. F inverse of x, oops, I didn't write that correctly, and let me put this inside here. So this time, let me just rewrite that. F inverse of f of x. So I want to compose it in the opposite direction. Again, here, let me write it here, that f of x was 3x minus 1, and f inverse, I'm saying, is 1/3 x plus 1/3. Okay. So here's my f and my f inverse, and I'm going to compose them. So this time I have f inverse of 3x minus 1 is equal to, okay, so now this is my new x, so I'm putting it into my f inverse. So I have 1/3 x plus 1/3 here. So I'm going to put in 3x minus 1 here. So again, I'm going to distribute here. I get 1/3 times 3x, which gives me x, and then I get minus 1/3 plus 1/3, and I have my x, and I verified it. So I found my inverse out doing a graph, finding a linear equation that fit the points, and then just to double check that I was correct, I composed them in both directions. Okay, so I will talk about more finding them algebraically next time.